Alright, this is the Chapter 3 video for the trigonometry midterm. We'll jump right in here in Section 1. Number 20. Find the exact value of the sine of 120 degrees. Well, in the beginning of Chapter 3, we were looking at reference angles, so let's draw the 120 degree angle in standard position. And when we're looking for a reference angle, it's what is the angle formed by the terminal side and the x-axis. So if the x-axis is 180 degrees all the way around, and this given angle is 120, the difference is 60 degrees. So the reference angle here is 60 degrees. What is the sine at 60 degrees? Well, sine of 60 degrees is the square root of 3 over 2. This terminal angle of 120 degrees is in quadrant 2, and if it's in quadrant 2, sine is positive. So then that would be the SIGN on the square root of 3 over 2 to answer the question sine 120 degrees. Positive square root of 3 over 2. Negative 150 degrees. We're working with the same structure here, except from the x-axis we're going negative 150 degrees. So that would be clockwise. And the reference angle would be the difference up to the x-axis, which is 30 degrees. Cosine of 30 degrees is the square root of 3 over 2. Cosine is negative in quadrant 3, where the terminal angle is. So the cosine of negative 150 degrees is going to be negative square root of 3 over 2. So this is how, again, just to review, we use reference angles to find exact values of sine and cosine. Number 36 encourages us to use our calculator to find cosecant of 166.7 degrees. And they ask us to round our answer to the nearest 10,000th, which is 4 decimal places. In the calculator, we need to make sure that we're in degree mode. We also don't have a cosecant button, but we remember that cosecant is 1 over sine. So sine of that angle, 166.7 degrees, if we divide 1 by that answer, we will get 4.34688, which rounds to 9. Question 74, in the way the question is worded, tells us several things. They ask us to find an angle. If theta is between 0 and 360, which means our angle is going to go counterclockwise, we're in the positive direction. It terminates in quadrant 3. So here's our angle. And we know that the cosine value is given there as negative square root of 3 over 2. It happens that the last question we did, we found that 30 degrees had a cosine of square root of 3 over 2. So I know that this is a 30 degree reference angle, and this would be 180 degrees. 180 plus 30 degrees, 210. That would be the angle in the third quadrant with cosine equal to negative square root of 3 over 2. Moving into section 2 of this chapter. This angle between cities. There is a picture for question 11, which is a very similar question in your textbook. I will sort of draw the diagram that they're talking about here. LA, New York in this problem. The radius of the Earth is given at 4,000 miles. And they say that the cities are approximately 2,500 miles apart on the surface of the Earth. And they want us to find the radian measure that's important of this central angle. We remember the formula to find the angle theta is going to take the arc length S, or the portion of the circumference of the circle connecting those 2 points, and dividing it by the radius of the circle. So 2,500 divided by 4,000 tells us that the angle measured in radians in this formula is 0.625 radians. Number 30, 25-minute period of a clock. How many radians does the minute hand of the clock move? So we have our clock, 12 and 6, 9 and 3. In between each of those are 2 hours. So in 25 minutes from 12 o'clock, it would go 1, 2, 3, 4, 5 of those 5-minute increments. If you divide 360 degrees by the 60 minutes, you'll find that 1 minute is 6 degrees. So you could take 6 degrees and multiply that by the 25, or you could take and say that each one of these sections is 30 degrees and there are 5 of those. However you choose, you can get to this angle being 150 degrees right here. So we travel 150 degrees, but they want the answer in radians, and so we needed to transfer or to translate from degrees to radians. We want to add the pi in, and so we multiply by pi divided by 180. If we were trying to go from radians to degrees, we want to get rid of pi, and so we would multiply by 180 over pi. This again is how I think about these transformations, not necessarily what you would see in the text. When we do this multiplication, you can simplify 150 divided by 180 to be 5 over 6, and the pi will remain. This way it's an exact answer. If you multiply 5 by pi and then divide by 6, you'll get a decimal approximation, and generally we won't do that unless they tell us to round to a specific answer. We'll keep the answers in exact form. On to the next section, where we looked at the third definition for the trig functions, and that was the unit circle. Now I've included that here in the video. You have it in the text, and there'll be one on Blackboard as well for you. questions like 28 and 30 are pretty simple with this definition of the unit circle, because if I want to find sine of theta, or I know sine of theta is negative a half, and I want to find the angle between 0 and 2 pi, this is telling me that they want the answer in radians in those directions. So I'm going to look for where sine is negative a half. Well, sine was the y value, and negative a half is here at 11 pi over 6, and sine is also negative a half here at 7 pi over 6. And since they wanted all of the values within a full rotation of the circle from 0 to 2 pi, that would be the answer. And then in the next question, they're asking for cosine of 0. So cosine is the x value, and I'm going to look at one of those quadrantal angles and see that cosine is 0 here at 90 degrees, or pi over 2, and also at 3 pi over 2. And our last section, 3-4, a couple problems from there where we started to look at arc length and central angles, but even more sector areas and such. So most of these questions here in our video are going to deal with arc length, and there are a couple questions, though, the odd problems, that deal with the sectors. So in number 8, we're given that theta is 2.4. Let me see if I can fix, there we go. And the radius is 1.8 feet. Now, you may remember the specific formula to find the arc length, but if not, and you remember to find the angle, it was the arc length divided by the radius, we could multiply both sides of this by r and find that the arc length equals theta times the radius. So since we're given the angle and we're given the radius and our angle is given in radians, that's important. Notice there's no degree symbol so that we know that it's in radians. 2.4 times 1.8 feet is going to be the arc length. And in this case, they did not talk about how to round, so I will just go to 4.32 feet. You could round to the 10th. I wouldn't necessarily round to the nearest whole number unless they say. So tenths or hundredths, that would be fine. Arc length. This is now a real-world example here, looking at the actual distance around a clock. The minute hand, so let's look at our clock here. Our minute hand is going to be 2.4 centimeters long, and that will serve as the radius. And in 20 minutes, how far did that travel? Well, again, as we talked about before, 1 minute is 6 degrees. And so if 1 minute is 6 degrees and we're going 20 minutes, the theta here is going to be 120 degrees. Unfortunately, in this formula, the angle has to be in radians for it to work. So I've got to convert 120 degrees to radians. And we do that again by multiplying by pi over 180 because we want to get to radians. Our degrees are going to cancel here as you divide those units, and pi radians will stay. So 120 divided by 180 times 2.4 is going to simplify to 8/5, and the pi will remain. This is going to be approximately 5.026, we'll say 5.03 centimeters. Now, because this is a real-world question, your answer in a decimal approximation with the units makes more sense than 8 pi divided by 5, or 8/5 pi. You know, what does 8/5 pi centimeters look like? How do you measure that? That's much more challenging than 5.03 centimeters. So a decimal answer makes sense here for that reason. Number 24 has a real-world example with the brakes in your car. This particular car we're talking about is a truck that's got an automatic transmission. It tells us that the diameter is 320 millimeters, so I know the radius is 160. And they want us to find this central angle written in degrees and radians. This central angle that would extend to the length of the brake pad at 335 millimeters in length. So the angle, which is what I'm trying to solve for, is going to have an arc length of 335 millimeters divided by 160 as the radius, millimeters. And just make sure that you pay attention to the fact that the diameter was given, but in this problem they need the radius. When you divide in radians, we have 2.09, and that continues 3, that'll just round to 9, we'll stop there. Radians, but they want it in both radians and degrees, so to convert into degrees we want to use the unrounded answer. Use not the 2.09, but in your calculator it's probably still there, so just use it unrounded. And we want to go 2 degrees, so we need to get rid of pi, so we're going to divide by the pi and have the 180 up top. When you multiply by 180 and divide by pi, that's going to be approximately 119.96. Let's just call that approximately 120 degrees. Hopefully this video, along with the other two, are helpful for you, whether you need to see every question or just a couple. Hopefully you found this to be a useful tool in preparation for your midterm exam.